All right, so we're going to finish up our material this week by looking at the second half of section 4.4. So in the first part, we looked at the transformations, and we looked at what the graphs look like on the calculator, talked a little bit about the principal roots, and then went over some basic terminology, right? The different words that we use to describe radical equations. So now we're going to look at sketching. Okay, when we sketch graphs, there's two different kinds of roots. Okay, there's even roots and there's odd roots. What was the kind of root that started at one point and curved just in one direction? Was those the evens or the odds? Those were the evens. Okay, so your roots generally look something like this, okay, if it's even. And what direction did the odd roots go in? Both. Okay. They would start here, and they kind of had a curve, maybe that did something like this side would curve this way, and this side would curve something like that. Okay, so when we're dealing with even and odd roots, even roots are the easier ones to sketch because you only have to figure out what's happening in one direction. Odd roots aren't that much harder. It's kind of symmetrical, but you do have to figure out both directions. Okay. With an even root, okay, I call this the start point. Okay, the start point is where the root starts, and then it curves in one direction. With this, I call it the center point. Okay, the center point is only something that you have to find with odd roots. So that is something I will ask you on the test, if the following graph has either a start point or a center point. Regardless of which one it is, that point always starts at the origin. Okay? Once we shift it, it's not at the origin anymore. So we've got to figure out, where did that point go? Okay? It was at the origin, now it moved. I'm going to show you how you find the x value and the y value of the new start point or center point. Depends if you're doing an even root or an odd root. To find the new x value of your point that was at the origin, you're going to set the radicand equal to 0 and solve. Can someone remind me from yesterday, what's the radicand? Yeah, it's the thing that's under the radical. So when you're talking about the radicand, we're looking at this. That's the radicand. So set what I just circled equal to 0 and solve. That will give you the new x value of this point. Once we get the x value, then we also need to find the y value. Well, you're going to have a formula that maybe looks something like that. Once you solve for the x value, you can take that, substitute it back in for x, do it all out, and that'll give you the y value. So you find the x value first, plug it back in, and then you've got the y value. Now that doesn't give you the whole graph. All that does is give you one point. It either gives you the start or it gives you the center, depending on what kind of root you're doing. We then need to find some more points. In the way that we'll find some additional points, we're going to use the table on the calculator. Have we used the table before? The table, second graph? Yeah. Okay, so we're going to use the table to get some more points. If you're doing an even root, I would say you probably need about 4 points. That's enough points to be able to kind of draw your curve. If you're doing an odd root, you might need like 5 or 6 points. You'll get the center, and then maybe a couple points to the right and a couple points to the left. Okay, and I'll show you what happens if you, on an even root, if you try to find points that are not in the direction it's supposed to curve. Okay, we'll look at what happens. Right. So I should be looking for values over here. If you try to do one over here, something's going to happen in the table. It's going to tell you that that won't work. All right, so let's try this one. So it's 2 times the cube root of 3 minus 2x plus 1. They didn't ask for this here, but if they did ask for how many transformations there are, just kind of review from yesterday, how many transformations are happening there? 4. Yeah, there are 4. All right, so let's sketch it. Bless you.
Thank you.
Is this graph going to have a center point or a starting point? Right, it's going to have a center because it is an odd root. So this graph is going to curve left and right. All right. Originally, the center was at the origin. We've now shifted it with all those transformations. How do I find the x value, the new x value of my center point?
3 minus 2x.
I take 3 minus 2x and set it equal to 0. So we'll add the 2x. And then last step to get x by itself. So yeah, we're going to add the 2x to the other side. And then divide by 2. Okay, so we get x equals 3/2. Okay, so there's the x value. Now, what do I do to find, this is my equation, how do I get my y value?
Plug it into x.
Yeah. Plug in 3/2 right here. Okay, so let's see what happens. What's 3/2 times 2? 3. Yeah. What's 3 minus 3? 0. What's the cube root of 0?
0.
0. And what's 0 times 2?
0.
Still 0. Plus 1. 1. So that number that's at the end, that's pretty much the number that tells you the y value. If this part doesn't come out to 0 when you plug it back in, then you did something wrong when you solved for x. Okay, because you set it equal to 0, so it should be 0 when you plug it back in. All right, so that's the center. Any questions on that? Yeah, this part will always be y. So as long as your equation is written in that format, the d is the y. Okay, everything else, if you did the x value correctly, it should come out to 0. But I would always plug the x value back in, because let's say you got 1 for x. Somehow you made a mistake. Well, if you plug it back in, you get 2 times 1 is 2. 3 minus 2 is 1. Right? That shouldn't happen. This should have come back out to 0, because that's what you set it equal to. So that's a good way to check your answer and see if you made a mistake. All right, now let's put that in. And we're going to use the table to get some more points. You don't have to use a graphing calculator on this step, but if you don't, you're going to need to pick x values, like maybe 5 of them, and you're going to have to plug them in for x one at a time and do it out 5 times. Okay, versus using the table, that's going to be a lot quicker. All right, so let's clear out anything else you already have in there. And we're going to do, this is how you type it all in. 2 times 3. And then you're going to hit math option 5. That's how you do 2 times the cube root. And then 3 minus 2x plus 1. Any questions on typing that in? So let's hit graph. Actually, no, I don't need graph. I need the table. Let's check 3/2. and make sure we got the right point. Yep, 1.51. That's the point we got. And then we want to pick a few to the left and to the right, because it's an odd root, goes in both directions. I would do like 3, 5, 10. That's some good ones to the right. And then let's do like -2, -5, -10. So I'll do those points. Okay, now I'm going to graph all those points and see what I have. Okay, so let's take this.
We're going to have to draw out the graph.
Oh, is it not?
As far as sketching, probably not on pair assessment by hand. I might ask you different things about the graph, like where's the center point, where's the start point, what directions does it go in, is this graph above or below another graph? So you have to know about the graphs, and you have to know how to make at least the sketch on the calculator too. But yeah, you're definitely going to have to be able to find center and start points by hand, and the calculator can't really give you those. Okay, so let's graph all the points. So 1.5, 1. 3, we're almost at -2. Right about there. 5, we're at almost -3. 1, 2, 3, 4, 5, almost -3. And then when we get to 10, we're just past -4. Okay. So there's the right part. Now we're going to do the left part. -2, just under 5. -5, we're a little bit under 6. There. And -10, we'll call it about 6.5. There you go. Zoom in so you can see it better. Okay. There's your points for your curve. And now just make your sketch. So it's going to kind of come down like this. Curve. And it continues in each direction, just like that. And that's your sketch. Any question on that one? Okay. Let's check it with the calculator and see how we did. Okay. What's going on with that gap right there on the calculator?
Too steep.
It's too steep. Yeah, it didn't do a good job. These are continuous. You should never lift your pen or pencil as you're sketching it. It shouldn't look like that. So that's where, if you rely just on a graphing calculator and you don't understand that that shouldn't be there, and you tell me that it has a gap in it, that's not right. And if you zoom in on it, you might even be able to get the gap to go away, depending on how you change your window. Or you might be able to make the gap look even bigger. Yeah, now it looks even bigger, but it shouldn't be there. All right. Any question on that one? Okay, so that's sketching an odd root. Now let's try sketching an even root. All right, so we've got 3 times the 4th root. It doesn't really matter what this index is, if it's a 2, 4, 6, 8. That's just going to change a little bit of how the graph looks, but it's still going to be an even root. It's still going to have a start point, and it's still going to go in one direction. All right, now, when we graph an even root, what direction does it normally curve in? Like it has a start point, and it curves to the right. It normally curves to the right. But what's that negative going to do? It causes a reflection. That's a horizontal reflection. So this one is going to curve to the left. All right, so it's going to be a root function that has a start point, but it is going to go to the left. So don't expect it to go to the right. If we try to check points to the right, in the direction it doesn't go, let's see what happens on the calculator. Anybody have a guess what's going to come up in the table if you try to plug in points in the wrong direction? Error. Yep, it's going to say error in the table. And that's telling you you went the wrong way. Okay. All right, so let's graph this. So we just said it's going to have a start point. What's going to be the equation that I have to write down to find my start point? Yep. 4 minus 3x equals 0. Okay. First step to get x by itself. Add the 3x. And then divide by 3. Okay. So the new starting point has an x value of 4/3. Right, and it's just going to be a -2, because when you plug 4/3 back in, 4 divided by 3 times 3 is 4. 4 minus 4 is 0. And 4th root of 0 is 0, and 0 times 3 is 0. Minus 2.
How come when I plug it into the calculator, like I plug in -3 times 4 divided by 3 gives me -4?
Can you tell me what you typed in?
Yeah, -3 parentheses 4 divided by 3 parentheses.
Just like that?
Yep.
So when you type that in, you got -4?
Yeah.
Yeah, that's correct.
But then wouldn't both the symbols make an addition? Is it?
So you're plugging in 4/3 right here, right?
Yeah, I plugged in 4/3 to -3x.
So when you plug in 4/3 right here, if you want to do it all out, like to check it, like you said, you do 4 minus, and then in parentheses, 3 times 4/3.
Oh, okay. So
That's
you
how
have
you-
to include the whole thing.
Yeah, this -4, what you did right there is this.
Yeah.
So if I put in what you had, you have 4, and then you got a -4.
Yeah.
So that would be 0.
Okay.
Yeah.
Oh, that makes sense.
So yeah, when you plug in 4/3, you do get 0.
Okay.
Okay, so we've got the start point. Now we need maybe 2 or 3 points to get the rest of the curve. So we're going to type that in. So 3 times 4, math, and then press 5. That's 3 times the 4th root, 4 minus 3x. Make sure you get outside the root for the -2. Okay, let's go to the table. If you want to clear the old values you had in there, you can. It's up to you. Let's type in 4/3. Perfect. 4/3, -2. And now, we know it curves to the left. Let's pick a value that doesn't go to the left. Let's try to find a value to the right. What would be a value to the right of 1.3? 2. Can't go that way. 5, 6, 9. Any of those going to the right of 1.3 are not going to work. So we need some that go to the left. Yeah, generally I like to do 0. That's always a good one. And then maybe like -4 and -8. Okay, those will be some good points. Okay, so any question why I got an error when I typed in those other numbers? The other thing is if you check it, like if you plug in 5 by hand, 3 times 5 is how much? 15. And 4 minus 15 is a negative number. We're not doing roots of negative numbers if the index is an even. You can't do the root of a negative number. Okay, so let's get our graph paper. zoom out so I can see my points. Okay, so we've got the start point, 1.3, negative 2. All right there. We've got another point, 0, 2.2. All right there. We've got negative 4, 4. And we've got negative 8, about 5. Okay. Back in. So I've got my points, and now just draw your curve. About like that. Okay, calculator should do a pretty good job with this one. I don't think there's any section that's too steep for it. So, well, actually, it does get kind of steep right in here. So, it might not do a good job with that. Let's see, it'll do a good job all the way up to that point, though. Yeah. See, that doesn't look right. Okay, when you look at it that way, it looks like the graph is actually stopping above the axis. Yeah, if we zoom in, watch what happens. Does it look like it goes below the axis now? Yeah, it looks totally different. So it is having a little bit of trouble. It's still not going down to where it should. It should be down at negative 2. It looks like it's only going a little above negative 1. And it's because it got too steep. All right, so again, that's why if you just graph it on the calculator, even if I gave you like a multiple choice, and I ask you which of the following is the correct graph, if you picked this
Hi, Mr. Hager.
Hi.
Sorry to interrupt.
Okay. So the last thing we'll take a look at is solving radical equations. So let me put that up and give you guys a second to copy that down. All right, so when you are solving radical equations, the goal is to get rid of the root. So the way you get rid of the root is if you have a square root, you raise to the power that would undo square rooting, which would be squaring, second power. If you had a cube root, what power would get rid of cube root? 3, cubed. Okay, so you have to raise each side to the power that would cancel out the root. Before we do that, we always want to make sure that the radical is isolated. So an example of something that's isolated would be like this. That's a square root problem where the radical is isolated. There's nothing else on the left-hand side except for the radical. Let's do that. That's an example where the radical is not isolated. So the first step you'd have to do here is take the 3, subtract it to the other side, and then you'd be ready to go. So any question what I mean about isolating the radical by itself first?
If there was a 2 right outside.
Like a times 2, like a vertical stretch?
Yes.
Mm-hmm.
It'd still be not isolated.
That's not isolated, nope. So you'd have to divide each side by 2 and then have the square root of x minus 3 equals 13 divided by 2 on the other side. Yep. And we do have to check for extraneous solutions. So remember, an extraneous solution is a solution when you try to plug it back in. It's not that you did anything wrong, it's just it doesn't work. Okay.
Will you be looking for those answers?
Would I be looking for them? Yes, it is possible that I give you a problem and say, solve it. If any of the answers are extraneous, tell me. And maybe I'd have a box that says extraneous answers go here, and answers that are not extraneous go here. Yeah. So, yep. And the extraneous answers are not something the calculator would be able to give you. It's only something you get when you solve it. So if you put it into a table or the calculator, I don't think it would give you anything helpful at all. Yeah, it just wouldn't. It wouldn't give you anything that would work. It would just give you a number, but the number wouldn't tell you anything. All right, so let's try this one. Okay, so it says solve algebraically. And so it's the cube root of x squared minus 2x plus 2 equals x. Okay. What power are we going to raise each side to cancel out that root? 3. Yeah. All right. So we're going to cube each side. That's going to cancel out the cube root. Okay, so that's gone. We have x squared minus 2x plus 2 equals x cubed. Okay. Any question on the first step?
Why wouldn't it be square root?
Why wouldn't it be the square root? So this problem doesn't have a square root in it. This problem has just a cube root. So when you cube each side, this root is now gone because the index on the 3 and the power of 3 cancel out. Okay. So now we have an equation that doesn't have any more roots in it. What do we generally try to get an equation that's not linear equal to when we're solving it? We try to get it equal to 0. And I generally like to make sure that the term with the highest exponent is a positive. So I'm going to move everything from the left over to the right. So we're going to have x cubed. We're going to subtract the x squared. We're going to add the 2x. And we're going to minus the 2. Okay, so x cubed minus x squared plus 2x minus 2. Any question on that? So no, we have to solve for x. So when we're done, the answer is like x equals 3. We have to get a number for the answer. Okay, so we have 4 terms. When you have 4 terms, and they're all different, like that, there's a type of factoring that we can try to do. It's called factor by, does anybody remember the name of it? Factor by begins with a G. Grouping, yes. We're going to do factor by grouping. So what that means is this problem has to be very special for factor by grouping to work. But if it didn't work, you'd be stuck and wouldn't be able to solve it. So I'm going to make sure it works. You look at the first 2 terms and factor out what you can. Then we'll look at the last 2 terms and factor out what we can. What do the first 2 terms have in common? X squared. So we're going to factor that out. If you factor out x squared, what would you be left with inside the parentheses? X minus 1. Now, the whole goal with factor by grouping is when you do it on the second part, you end up with x minus 1 again. If you don't, then you can't do factor by grouping. Okay. What can we factor out of the last 2 terms? Just a 2. Positive 2. If you factor out a 2, what would you be left with? You'd be left with x minus 1. Because 2 times x is 2x. 2 times negative 1 is negative 2. All right, so now you look at this and this. What do each of those have in common? X minus 1. So now we're going to factor out the x minus 1. If you factor out x minus 1 from that first part, what's the only thing that's left there? X squared. If you factor out x minus 1 from the second part, what's left? Plus 2. So now we factored it, and the only way 2 things can multiply together to give you 0 is if what? One of them has to equal 0. So let's set each factor equal to 0 and get our 2 answers. So So now we've taken what was a really complicated equation and we've simplified it down into two much, much simpler equations. What would you get from this first one?
1.
X equals 1. Okay. Now, on the second one, what would be our first step? We would minus the 2. And the second step, we would try to take the square root of both sides. What's going to happen when we try to take the square root of negative 2?
Give you imaginary.
That would be imaginary, right? Because that's imaginary, we're going to stop with that because we're not looking for imaginary answers, we're looking for real answers. So if you get to a situation where you're taking the square root of negative 2, you can, or negative number, you stop with that. There's no answer from this part, but there was still an answer from this part. Okay.
Would you want the imaginary answer from the text?
No. Nope, I wouldn't want the imaginary. What do we have to do now, the last step with that one? Plug it in, check it, and make sure it works. Okay, so let's check our original problem. What's 1 squared? 1 minus, what's 2 times 1?
2.
So minus 2 plus 2. Okay, so let's do out this part that's right here. What's 1 minus 2? Negative 1 plus 2. 1. What's the cube root of 1? So we get a 1 on the left. And originally, that's what we had on the right. X was, and we're plugging in what number for X? 1. Does 1 equal 1?
Yes.
Yes. Then that works. If it was extraneous, okay, what would have happened is you would have gotten something like 2 equals 3. Or something. You would have got one number on the left and a different number on the right.
What would happen if you plugged in imaginary?
If you plug in the imaginary, then you're going to be trying to deal with like the cube root of an imaginary number. And if you try that on the calculator, let's do math. You can do cube roots of imaginary numbers, like 3 plus 2i. I got to make sure I'm in imaginary mode, but you're going to get these really complicated looking answers. So it is possible that the imaginary answer could work, but it's not something that we're going to look at in this class. But it is possible that it could work. Yeah. Any other questions on that one? Okay, so that one was a cube root. Let's try this one. Let's do 3 plus 2 times the square root of 4x equals, let's do 11. Okay, what's the very first thing we have to make sure of? And in the last problem, it was already done for us, but in this one, it was not.
Isolate the radical.
Isolate the radical. Yes. What would I have to do first to isolate this radical?
Subtract 3.
Right. Okay. If you get kind of stuck on it, just pretend like you don't even see the radical. Think of it as like a black box. And think of what you have to do to get that black box by itself. So minus the 3. That's gone. And now you have 2 times your radical. And 11 minus 3 gives me 8. Okay, and last step to get that radical by itself. Divide it by 2. So I have the square root of 4x equals 4. And what would I do on both sides? Square it. square and square, those cancel. I get 4x equals how much? 16. And what's my last step? Divide by 4. And what is 16 divided by 4? 4. Okay, let's check it. Plug it back in. 4 times 4? 16. What's the square root of 16? 4. 4 times 2? 8. 8 plus 3. Perfect. Yep. So that answer works. Any questions on that? Now, algebraically, we just did it. Graphically, well, it's kind of like what we've done before. Do a y1 and a y2 and then see where they cross. 3 plus 2 square root of 4x. And then put in 11. I'm going to do zoom 6 just to reset my window. But I know I need my y max higher than 10 because I need to see to 11. So there's your square root. There's the line at 11. And these should intersect exactly at the answer we just found, 4. Okay. Any questions on that?
They never intersect again.
No, they can never intersect again because the root is just going to keep going up forever, and the horizontal line at 11 stays flat, so it won't ever cross again. Any question on that? All right, the last one. The last one is just solving graphically, very similar to what you did in 1 through 4 in the homework. All right. So the trickiest part is by just typing it all in. Can anybody tell me the buttons I need to press to type in the left-hand side? 5. Math. And 5 again. Yep. And now just 9 minus x squared. And then for y2, x squared plus 1. Okay, so I'll put this here so we remember the colors we're using. And we're looking for where the fifth root is greater than or equal to the red one. So where the blue one is higher or equal to the red one. Okay, so let's do zoom 6. All right, let's look at that. First of all, does it ever look like the blue one is above the red one?
Yeah.
Yeah, it is. Is it a big area or is it a small area where it's above the red one? Very small. There's only a really, really tiny section where the blue one ever goes above the red one. How am I going to figure out how big that section is? What do I have to find? Yep, I need 2 intersects. So let's do the one on the left. Okay, so there's 1. And let's do the one on the right. It might be symmetrical. It could be negative 0.73 and positive 0.73. I would say it probably will be, but I would never just assume that. Okay, so we've got each intersect. So what's the lowest value we can pick to be on that green section right there? Negative 0.73. And can we include or not include it?
Can't include it.
We can include it because it doesn't say it has to be above, just above. It does say it can equal. So what symbol would we use? Bracket. And what's the highest x value you could pick and still be on that green section? 0.73. And we can include it for the same reason. Any question on that? So that's the last part of 4.4. Okay, solving graphing the inequalities, and then solving algebraically by squaring or cubing both sides. So let me put up the homework. Okay, so the homework tonight is on page 255. It's numbers 12 through 15, 19 through 23, and 31 and 32. Okay, so tomorrow we will have a review day. We'll go over everything from this week, and then we'll have our last test for the quarter on Friday.